Ladies and gentlemen, thank you for tuning in. We have a rare opportunity to exchange few words of wisdom with Harry Mendell, who is a data architect of the Federal Reserve Bank of New York.
Happy to be here. Before the questions start, I'm required to say that everything that I say is my personal beliefs and not necessarily those of the Federal Reserve Bank of New York.
Of course, for entertainment purposes only. Harry,
Yeah.
let me start with that. What does data architect do?
So, as you can imagine, we have a lot of data at the Federal Reserve, and we need to design systems that analyze them in a way that is efficient, secure, and that's what the data architects do. make it work.
Okay, as long as it works, right?
It has to work securely and accurately.
When you say data architect, it makes me think of the movie Matrix, where there's this architect that creates the whole Matrix thing. Is that something?
That's exactly it.
Exactly.
Yeah.
All right. Let's delve into some more important details. So, Harry, do you believe that the superintelligence will emerge through scaling larger LLMs, as many companies are betting on nowadays?
I actually think it's going to require more architecture, more design, and thought into the algorithms. I don't think that simple scaling will get us there. I think that LLMs do a great job of learning skills, but the way they learn the skills is by training on data, representing everything on the internet, everything that people have done. And then after that, through a process of human feedback and reinforcement learning, their answers are perfected and skills are taught. The first skill that was taught, most people don't realize this, was language translation. The transformer architecture was designed for that purpose. And it had to be taught how to do it properly because it would make mistakes in the beginning and they give it corrections. And after that, people wanted it to be conversation. LLMs don't naturally converse. You have to put them in a loop where you feed back what they say back into them with what the person said, and it keeps building up. And they had to be programmed on how to do that properly, again, through a training process. They also had to be trained to follow instructions. None of this is natural. Every task that the LLMs do, they're trained to do. Programming was another example. So I think they can be trained to learn all kinds of skills which will, in some cases, replace what people do. But it's not that they're going to come up with something new with this present architecture. They'll only be able to learn patterns, skills, and how to do things. I mean, even the thing that I think interesting is before this, only living things had skills, right? So that's a big difference. I mean, even ants know how to build, ants. Bees know how to build a hive, but machines didn't know how to build anything until this.
Are they going to know soon?
Well, they do now. They know skills. They just don't teach themselves new skills.
Not yet.
Not yet. And they have other limitations as well. Reasoning is another limitation. Right now, the way they reason is by being given the opportunity to generate a lot of answers, each one somewhat different. And then they have another process which chooses the best answer. So it's not a step-by-step process.
What is the biggest shortcoming and this very specific point in time of the LLMs?
That they don't learn anything new from when they're created. So during the training process, all the information that's presented to them is turned into weights, which make the LLM work. And it's a complicated process where it goes to try to answer questions, answers them incorrectly, and through convergence, through optimization, learn how to do things properly, but only up to a certain date. New information comes in, they don't absorb it. Now there are ways of allowing it to search on the internet to get new information, or you can present it with new information, but it doesn't learn it in the same way as it does the information that it learned during training. I can give you an example. Anyone that's used an LLM or ChatGPT knows that when you ask it to plan something for you, it might make a little mistake here and there. For example, I was just in Paris 2 days ago, and it was raining, and I said, "Oh, I've got tickets to come at 12:30. They won't let you in before that, but I would like to come earlier because it's raining now, and there's nothing else I want to do." And it said, "Well, you can come early, and you can go to the gift shop, and you can go through security and do these other things, and then about half an hour before your time ticket, the guards will let you in. So I said, great. So we went over to do this and found out that as soon as you get into the line to go into security or even the gift shop, they look at your ticket and they say, no, you can't be in this line. So this is the kind of thing. And the reason that happens isn't that it couldn't pull the information from the internet telling that, it's that it didn't have an interactive training loop where it tried to propose things, had people look at the answers, correct it, and refine a solution.
I see. I asked about shortcomings. Now, what improvements in LLM's design would you like to see that do not involve super intelligence?
Memory. So one of the things that researchers are actively working on but haven't come up with a practical solution for large language models is that they can continuously learn. The only way to do that now would be to retrain them periodically, like every day, and that's too expensive. So
When you say retrain, that would be starting from scratch all over?
yeah, basically.
Really?
Almost from scratch. There are things they start from which are not entirely from scratch, but it's much more than fine tuning. So they pretty much are from scratch. And that wouldn't be practical, it'd be very expensive. I mean, it could be done assuming processors get faster and faster, but it's sort of an ugly solution. What would be better would be in real time as information comes in, that it could adjust and test the weights so it would incorporate new information the same way it did when it was trained. And that wouldn't have the problems that retrieving information and using it in the context have presently.
Right. Hypothetically, let's presume there's data points over the internet or whenever over the realm, which large language models are not aware of. What would happen if, let's say, this data point all of a sudden is being entered or discovered by somebody, and then what that would mean in overall rearranging of that whole model? Let's say we have like premise of the world as it exists, as we know, as we learn, I don't know, from history, for example. So, and now we all of a sudden have data points which we were not aware of.
So it would make use of them if it was part of the training data, and that would cause it to be able to incorporate that new knowledge in solving problems, which would be, would be a good thing. And in fact, this happens every time they train these models. They do find new data. And by the way, data is being collected all the time to improve these models. One of the things which they're looking forward to do with all these glasses like that Meta has and Apple's coming out with is to collect data from what you're looking at and what you're doing through your day, which will feed the training beast to create, much more knowledge.
You said it, beast, right?
Yeah.
Is that what it is? That's what we're up
That's
against.
just a fun expression.
All right, I'll take it on that. What are the agents and how powerful are they? And what are their strengths and weaknesses? And because everyone is talking about agents as if they are replacements for workers. Could you explain what agents really are and how they could replace employees?
Yes, I don't believe that they're direct replacements for workers, but the use of them could displace. And let me explain what I mean by that. So an agentic system is a way of modularizing a business process. So you don't want to give a chatbot a big instruction like run my accounting system or something like this. This is not going to work, obviously. But if you take it and break it down into pieces, by the way, computers have been used for this for the past 50 years. As soon as they were put into business, programmers figured out ways of breaking down business processes into programs, writing the programs, and having them be automated. The difference with agentic systems is you don't have to create a platform to do this every time. You can give instructions and very easily create business systems by explaining each part of the system. But you still need to have an expert that knows how to do this in terms of business logic. You can't just say, replace my ad tech system with this thing you're building, because it's not going to have the knowledge or capabilities to figure out how to do that. But if you have people break it down into modules, figure out how to orchestrate it, and do all those steps, it's still a lot less than writing specialized software to do it. So it's a way of achieving that easier.
So you said that bookkeeping, for example, accounting wouldn't be possible at this time, or
Oh, it
eventually
is. But I'm saying it's already being done
Yeah.
by by programs you can get from IBM or SAP or all these other systems, platforms which people buy to do business. So things like Salesforce has solutions for that. But for more complicated things, which,
like Federal Reserve.
yeah, I mean, there's certain ways the Federal Reserve could certainly use agentic technology to be more efficient, to do things faster, right? To do the analysis of the economy in a more efficient way, to examine banks faster, to find risk quicker, things like that.
And in conclusion, how does one go about utilizing agentic systems? How effective are they?
In the right hands, they can be extremely effective. But you can't treat them like they're a magic genie in the bottle and just ask for
No.
something.
I'm disappointed,
Some
Harry.
people are advertising them like they can, and that they're like little people and they need their own HR departments and all this nonsense. But in reality, the way you use it is there's two ways. A person can use it individually, which is the easiest way, to expand what they're doing. They can automate things in their life which they do, which are mechanical. They can plan things for you. They can organize your email. They can do all these kind of things. There are people that have businesses where they get phone calls in, they have to dispatch things, simple things, deliveries. That can all be done agentically and easily by simply, because there's not a lot of logic or reasoning to these things. There's sort of reflexive responses to the inputs coming in and just being able to do things. But let's say you have a large department and you want to collect data from all these different sources. Instead of having people process each little bit of data and examine it for quality and move it on, you could break that process down into modules and have an agentic system do it for you. But you need a subject matter expert in that business process.
Right, to oversee this whole thing.
Right. Yeah.
Yep. Well, let me finish with that then. Where do you see all this going? Let's say, that's your opinion, of course. Let's say next 10 years.
I see it becoming a more and more useful tool. And I think it's part of the technology progression that we've had since the Industrial Revolution. When they first invented, electric lighting, it took a long time to light up things. It took a long time to figure out applications for motors. If you want to laugh, look up what one of the first ones are. It's funny. And then we got more and more clever and built factories, and now we have electric cars and subways and things like this, and it keeps expanding. This will do the same thing for knowledge work. So you'll progress in the ability to analyze, process information, and understand data better, but it'll be a continual expansion. I don't believe in the singularity. I don't think that all of a sudden, as the theory goes, AI will be able to design a better AI, and then that will design a better AI, and before you know it, you've got this superior intelligence that looks down upon,
It's such a relief.
I really think this is a sort of paranoid fantasy, similar to ones where people have where aliens are going to come and take them away and they drink Kool-Aid, this kind of thing.
It very well may happen.
There's no actual evidence that this can happen.
Well, let's hope it won't. Harry Mendell, data architect with Federal Reserve Bank of New York. Thank you so much, Harry, for your time. I appreciate it. Signing off.